What we started doing yesterday is called trigonometric ratios of half angles, right? So we did a couple of numericals yesterday. Today we'll continue and then we'll start a new topic in Trigo. All right. So if I have a numerical like this, prove that cos x by 1 minus sin x is equal to tan pi by 4 plus x by 2. Right? So who can help me with this? Can I try with Keshav?
Yes, sir.
How do I do this, Ma?
So I think we have to change cos x into the formula for cos x by 2, and yeah, we'll do that first.
Okay, because then you can get rid of this one, right?
Yes, sir.
So I will take your suggestion. Let me try that, okay? So I'll keep this as cos x itself. And then I'll change this as 1 minus cos of 90 minus x, right?
Yes, sir.
So why did you choose to do this, Keshav?
So first I thought I'll eliminate the 1, and then we can add a 1 on top for the pi by 4. And then I don't know, so that's all I planned until now.
Okay, so it's always good to have an idea how we have to do it. Remember, we are doing this in half angles, right?
Yes, sir.
That means it's not cos x you should see, it is as if it is cos 2 into x by 2. You're able to understand, right?
Yes, sir.
Don't look at it just as cos x. It's as if it is cos 2 into x by 2. You must remember this. Okay. So once I write it in this way, what will I get? I keep this cos x divided by, what should I do in the denominator?
So we have to use the formula, the 2 cos square x minus 1.
So 1 minus.
So it'll be sine square x formula, the 1 minus sine square x.
Okay. So 2 sine square x minus 1. Here it is going to be x by 2 minus 1, right? Whatever the angle is there, I have to take half of that angle. But what is my angle here?
Pi by 2 minus x.
Pi by 2 minus x is the angle that I have with me. So if I want half of that angle, I want theta by 2. That means I need pi by 4 minus x by 2. Isn't it? So if I take this whole thing as theta, because I need x by 2, right? That will become pi by 4 minus x by 2. Okay. So how will this look now? 1 minus, within brackets, 2 sine square half of the angle. 2 sine square half of the angle, I got it as pi by 4 minus x by 2, correct?
So it's minus 2 sine square, right?
Huh? 1 minus, right? 2 sine
Yes,
square, pi by 4, 1 minus, right? Sorry.
Yes, sir.
So 2 cos square x minus 1, 1 minus 2 sine square x by 2. The formula for cos 2x is 2 cos square x minus 1 or 1 minus 2 sine square x. Therefore, for formula for cos x will be 2 cos square x by 2 minus 1, 2x, x, x by 2. Or cos x is going to be 1 minus 2 sine square x by 2. So we have to use this one, right, Keshav?
Yes, sir.
All right. So 1 minute. All right. So here I have to take it as cos x by 1 minus 2 sine square half of this angle pi by 4 minus x by 2. By doing this, what we are achieving is 1 minus 1. So the 1 in the denominator is getting eliminated. Minus of minus is 2 sine square pi by 4 minus x by 2. That's what I'm having now. What to do?
So maybe we can change the cos x to pi by 4 plus x by 2.
I can change the cos x to?
So we can change the cos x to the cos formula. So the 2 cos square x minus 1, or cos square x by 2.
Yeah, but here if I see, no, I'm getting pi by 4 plus. Here I'm having pi by 4 minus.
Yes, sir.
Okay, so when I'm changing sin x as cos 90 minus, right, it is always going to remain as pi by 4 minus x by 2. How do I get rid of this? And I'm having something tan out here. Here, this cos x, I can write it if I just want to continue. Okay, cos x, I can write it as sine of 90 minus x, right?
Yes, sir.
And this, I can take it as sine 2 theta. I can take it as sine 2 theta. So sine 2 theta is 2 sine theta cos theta. So I can get 2 sine half of this angle pi by 4 minus x by 2 into cos pi by 4 minus x by 2. Okay, so here I have 2 sine square pi by 4 minus x by 2, correct?
Yes, sir.
So if I knock this off, I will get cot of pi by 4 minus x by 2 is the answer. Okay, let's just try it a bit, then we'll see where it goes. Okay, so I will say cos x is nothing but sine 90 minus x. Sine 90 minus x. Okay,
Yes, sir.
divided by 2 sine square pi by 4 minus x by 2. Okay, and then I use sine, this is sine 2 theta formula. That means in my mind I am converting it in this way. I will be doing just for the first few times so people understand what's happening here. Right? I'm just taking 2 out, dividing it by 2. So pi by 4 minus x by 2, 2 I'm multiplying and dividing by 2, right? Then this is now like sine 2 theta. This is our theta now, right? So I can write this as 2 sine theta, that is pi by 4 minus x by 2 into cos theta divided by, okay, now if I cancel this out, I get cot of pi by 4 minus x by 2. Correct? Huh?
Yes, sir.
Okay, but here I need it in tan. So I have cot pi by 4 minus x by 2, but I need tan pi by 4 plus x by 2. Any suggestions how I can get this done? If you look at tan, right, let's see how to convert tan and cot. Huh? What is tan cot 90 minus theta.
So tan theta.
Okay, so can I write cot theta as tan of 90 minus theta?
Yes, sir.
Because I have cot, I want to go for tan. So cot theta is equal to tan 90 minus theta. So I can say this is nothing but tan of 90 minus whatever we have. Can we do this?
Yes, sir.
Then if I do this, I will get this as tan of pi by 2 minus pi by 4. I'll write it out. Pi by 2 minus pi by 4, minus of minuses plus x by 2. Okay. See, slowly we are getting that plus out here. Pi by 2 minus pi by 4 is how much?
Pi by 4.
Okay, if you want just between these two guys, 2 pi minus pi, isn't it? So did
Yes,
we
sir.
get it?
Yeah.
Okay, so I can write this cot as tan of 90 minus theta and then get this as tan of. Is it okay?
Yes, sir.
So once again, remember we are playing around with half the angles, half of the trigonometric angles. Okay, so we have to uh, develop the habit of breaking up this into x by 2, right? Go ahead and make a note of this. And any questions you have, please ask. Guys, did you get it? Any doubts?
Yes, sir.
No doubt, sir.
No doubts, no? Good. Hannah, any doubts?
No, sir.
It's okay, no? All right. So let's move on to the next one. See, in fact, this numerical, we could have done it in another way also. See, when you have this cos x, right, you can write cos x as there is one more formula for cos 2 theta. Now, what is that? Cos square theta
Cos square x minus
sin
sin square.
Okay. So cos theta therefore will be half of the angle cos square theta by 2 minus sin square theta by 2. Do you agree? So
Yes, sir.
top I'll write this as cos square x by 2 minus sin square x by 2. And bottom, no, I have this 1. 1 can always be written as sin square theta plus cos square theta. Because I have everything x by 2, I can also write this as sin square x by 2 plus cos square x by 2. Because x by 2 is just an angle. X by 2 is like alpha, sin square alpha plus cos square alpha. As long as the angles are same, sin square of the angle plus cos square of the angle is always equal to 1. So I can write this as cos square x by 2 plus sin square x by 2 minus, this is sin x. Sin x is nothing but sine of 2 into x by 2. I can write this as 2 sine theta. This is going to be my theta. Sine 2 theta. 2 sine theta cos theta. 2 sine half the angle cos half the angle. Then what I see here, this is, Hannah, can you tell me what is the bottom form resembling?
Sir, a plus b the whole square?
Plus
No, sorry, sir. A minus b the whole square.
a minus b the whole square. Very good. So, and on top, what do you see this form as?
A square minus b square.
Very good. So, can you help me expand that in that form?
So it will be cos square x by 2.
That is cos square is a square minus b square.
Oh, sorry. Cos x by 2
Very good.
plus sin x by 2.
Very good.
Close the brackets. And it will be cos x by 2 minus sin x by 2.
Very good. And bottom?
It will be cos x by 2 minus sin x by 2 the whole square.
Okay. What will be your next step?
So we can cancel cos x by 2 minus sin x by 2 in the numerator and the square.
Very good. So what we are left with is this. Is it okay? Now,
Yes, sir.
whenever you have cos theta plus sin theta by cos theta minus sin theta, okay? And you need to head to tan. So you have tan of pi by 4 plus x by 2, okay? So you have you have this form here on the left hand side. Cos x plus sin x by cos x minus sin x. What you do is you divide the numerator and denominator by cos x. Okay, you divide the numerator and denominator by cos x, right? So here, instead of cos x, you divide the numerator and denominator by cos x by 2. Okay, so tell me what will happen then.
So it will be 1
Very good.
plus tan x by 2.
Fantastic.
and then in the denominator it will be 1 minus tan x by 2.
Very good. So next thing you should remember is when you have 1 plus tan x and 1 minus tan x, right? There is a expansion for tan x. Okay, the tan expansion is tan of a plus b is tan a plus tan b by 1 minus tan a tan b. Okay, so whenever you have 1, right, if you compare it to ours, we have 1 minus tan x. So this is, tan a has become 1, right? So what shall we do there? Any ideas?
Tan pi by 4 is 1.
So tan pi by
So
4.
instead of tan a, you can write it as tan pi by 4 plus tan x. Are you able to understand? So you can write this as tan pi by 4 plus tan x by 2 divided by 1 minus, because we want that form, 1 minus tan a tan b. Tan a, you will write it as tan a, you will write it as tan pi by 4 into tan x by 2. Okay, because you know this is, if you have it in this form, this is all like visual recognition. You have to apply your mind. When 1 is there, you can write 1 as tan pi by 4. Okay, then it becomes tan a plus tan b by 1 minus, I have a 1 here. That 1 can be written as, once again, tan pi by 4. So this becomes tan a plus tan b by 1 minus tan a tan b. That is nothing but tan of a plus b. This is a, this is b. All right. So there are 2 ways and perhaps a few more ways to do it. But these 2 ways are good ways to do. Okay, why I wanted to do this is, when you have this, I wanted to want you to remember this. When you have this cos x plus sin x divided by cos x minus sin x, okay, you always have to practice dividing numerator and denominator by cos in order to convert it into tan. Okay, remember this trick. Okay, and then when you have 1, having the presence of mind to convert that into tan pi by 4.
So I didn't understand the last step. What happened to the denominator?
What happened to it? The whole thing does, see, this when you divide, no, cos x, 1 by cos x, okay? So I will write it for you.
You get 1 plus tan x by 2 and divided by 1 minus tan x by 2. So after that, what happened? What happened to the denominator?
See, just look at me. Cos x by 2 plus sin x by 2 by cos x by 2, correct? Yeah. Divided by cos x by 2 minus sin x by 2 by cos x by 2, correct? No?
Yeah.
Same thing, the numerator I have taken separately here, divided by denominator, okay?
Yeah.
Numerator, what it became, 1 plus tan x by 2 divided by cos x by 2, okay? Sorry, this is not there. It's going to become 1 plus tan x by 2, correct?
Yeah.
Divided by 1 minus tan x by 2, correct?
Yeah.
So that is what it is. 1 minute. So what we have with us is 1 plus tan x by 2 on top. 1 plus tan x by 2 on top divided by 1 minus tan x by 2 at the bottom. Correct, no?
Yeah.
Then this we are writing as tan pi
by 4
plus tan x by 2 divided by 1 minus. Here 1 is there. Okay. So you say tan pi by 4 into tan.
Oh, okay. That's a step I didn't get.
Because what we are telling is this is like adjusting, right? I know
Yeah.
tan of a plus b is tan a plus tan b, but 1 minus tan a tan b. So by writing this as tan pi by 4, upar wala, we got it, this form. 1 minus is also there. This also we have. Now we need an extra tan a. That extra tan a is writing off this 1 in front. Tan x by 2 is 1 into tan x by 2. That we are putting off tan pi by 4. Just for us to get the same form. Okay. Then we get this as tan of pi by 4 plus x by 2. All right?
Okay, sir.
Right. Now, this is enough as far as our half angles goes, trigonometric functions of half angles goes. Now the next part which we have to do is identities involving angles of a triangle. Okay, so this heading, this is kind of important, this particular topic. Okay. Means here, whatever ABC you get, right? He is going to tell you these A plus B plus C is equal to pi, because all these in these numericals are going to be the angles of a particular triangle. Okay. So he will tell if A plus B plus C is equal to pi, then prove that sine 2A plus sine 2B plus sine 2C is equal to 4 sine A, sine B, sine C. Okay, so here you have sum, here you have product. And one extra condition is given here for us, A plus B plus C is equal to pi. Okay, so we will have numericals which are of this pattern, right? How do we go about this? Nihar, any suggestions from you?
So not sure. I'm thinking.
See, we have sine here, sine here. Just observe this.
Okay.
Observe this and tell me what comes to your mind. If anyone else is also getting an idea, you can share. Adit, any ideas from your side?
Sir, I'm thinking.
Neha?
Sir, I am thinking one second.
Keshav?
Sir, I thought maybe because it's 4 sine A, sine B, sine C. And sine plus sine is 2 sine cos, sine A plus sine B.
Don't jump into the solution. See, you see sum here, you have product here, right?
Yes, sir.
And we know, right? We have our in our kitty sine plus sine.
Yes, sir. So it will become 4 if we add all of them.
You can, this is sum. we know formulae to convert it into product, isn't it?
Yes, sir.
So that is what we need to use here, right? The moment you see this is sum here, this is product here. I know I can take two of these guys at a time, and I can convert a sine plus sine as a sine into sine, isn't it?
So sine to cos.
Sine into cos, right?
Yes, sir.
All right. So what will you do here?
So I thought first we'll take sine 2a and sine 2b.
All right. Let's take it and apply the formula for sine plus sine. What is the formula for sine plus sine?
So it's 2 sine cos.
Okay. Sine plus sine is 2 sine a plus b by 2 into cos a minus b by 2. Correct?
Yes, sir.
All right. So when we are coming from sum to product, you have to divide it by 2. We'll use it. Can you please help me in putting it in this form?
So it's 2 sine a plus b cos a minus b.
Okay, because you're telling it is 2a plus 2b by 2, 2a minus 2b by 2. So it's going to become a plus b and a minus b. Correct? That's what you're telling me, right?
Yes, sir.
2 sine a plus b into cos a minus b
Yes, sir.
plus sine 2c.
Yes, sir.
Sine 2c, can I write it as 2 sine c cos c?
Yes, sir.
Okay. Now, we have a plus b, a minus b, 2 sine c cos c. Why did this guy tell a plus b plus c is equal to pi?
So because they're in the same triangle.
They're same triangle. How can I make use of this?
So a plus b is pi minus c.
Yeah, we say, hey, if I have a plus b, I can always convert this into pi minus c. Good job. So, Nihar, can you please help me in doing that conversion? 2 sine.
Yes, sir. Pi minus c.
Hmm.
Then do we convert a? Okay. No.
We leave it as it is because we have nothing for a minus b, right?
Yeah.
Now, what is the next step we should do? Sine 180 minus theta. What will we get?
Sine c.
2 sine
2
c.
sine c.
What is the next step?
So can we take 2 sine c out?
Very good. You take 2 sine c out, then you get cos a minus b plus cos c. Okay, now you look at our result because we can't predict the entire sum how to do it, right? First we saw plus, we know product is here, one step we converted, and you have a plus b, I can convert it, I'll do it.
So you have
Now,
to convert the part in the square brackets somehow to 2 sine a sine b.
So it's in the form of cos a plus b, right? Cos a plus cos b.
Yeah.
So
yes, so it is in the form of cos a plus cos b, cos plus cos, right?
yes, sir.
So one other thing is, here you have a minus b, right? Instead of cos c, can I somehow now write it as in terms such that I get a and b?
So pi minus a plus b.
Very good. A plus b plus c is pi. Therefore, I have c. I can write it as pi minus of a plus b. Correct, no? So that will become 2 sine c into cos of a minus b plus cos of, inside it is pi minus a plus b. Okay, then 2 sine c cos a minus b plus, what is cos 180 minus theta?
Minus cos.
Cos 180 minus theta is minus cos theta. So I'll write it as minus cos theta is our a plus b. Right? Now we got this as cos x minus cos y. Cos x minus cos y. Right? What is the formula for cos minus cos?
Minus 2 sin
Minus
z.
2.
Minus 2 sine x plus y by 2 into sine x minus y by 2. Correct? Cos minus cos is minus 2 sine sine. So I'll write this as 2 sine c into minus 2. Okay? I have to put minus, right? Minus 2 sine a plus b. That means a minus b plus a plus b by 2. Correct?
Yeah.
Into sine x minus y. A minus b minus a minus b by 2. Correct, no?
Yes, sir.
So it is a minus b minus of a plus b, x minus y. So a minus b minus a minus b I'll get by 2. That means this is minus 2 sine c. This b and this b will go. 2a by 2 is 2 sine. 2a by 2 is a. So we got the sine a also. Okay. And 2 into 2 we got 4 also. Very good. This somehow has to go off. Sine a minus a. This also
Sine
will
minus
go.
b.
Minus 2b by 2. That means sine of minus b. Right? We know that sine of minus theta is minus sine theta. Correct? So we can write this, take this minus out, convert this into a plus. Then we get 2 into 2, 4. Sine A, sine B, sine C. All right. So this is like a very popular numerical which they will be asking in the exams, right? Identities involving angles of a triangle. So most of the time you will see it this way. You have sum of some angles here, you have a product of some angles, and they will give you A, B, C are the angles of a triangle. The moment you get that, it should flash to you that you have to do it in this way. Is it okay? Can you please make a note and ask me if you didn't understand any part of this? Guys, any doubts, any questions?
No doubt, sir.
No, sir.
Paka,
Yes, sir.
Hana, Rakshita.
No, sir.
No doubt, sir.
Now let's move on to one more type. Okay. Let's take one in cos and c. Okay. The same thing. If a plus b plus c equals pi, prove that cos 2a plus cos 2b plus cos 2c equals 1 minus 4 cos a, cos b, cos c. Okay, the last one you didn't have this 1 minus. You just had a pure product. Now you have 1 also here. Okay. Adi Sunil, can we try together?
Yes, sir.
Okay. So, Karan, are you there, Karan? All right. So, what is the formula for cos x plus cos y?
2 cos x plus y by 2 cos x minus y by 2.
Very good. So, I'll just write it. Cos x plus cos y if I have, it is going to be 2 cos x plus y by 2 into cos x minus y by 2. Okay, I will remember this. Then I will take these two guys and try to get them in the product form. Tell me how I should do it.
It should become 2 cos a plus b
Okay.
and cos a minus b.
Okay. Some mistake.
So,
I write
yeah, there's no
cos.
There's no cos outside.
Here.
Yes, sir.
Plus cos 2c. Okay. Then let me, before I decide what to do with this, we'll try to massage inside. Okay. What can I do? Once again, this a plus b is nothing but pi minus c. Okay. So I have written this somewhere wrong way.
Yeah,
Right?
so there's no cos inside the bracket.
You've
No,
put
no.
cos outside
Just give me 1 minute.
and you erased the wrong cos.
Yeah. Sorry. Okay, this is cos of a plus b into cos of a minus b.
And the 2.
Okay. Now, a plus b is nothing but pi minus c. So I'll say 2 cos pi minus c cos a minus b plus cos 2c. Cos 180 minus theta, now I know, is minus cos theta, right?
Yes.
Okay.
So do we go cos 2c?
Yeah, because I see cos c out here. Cos c is here, right? That means this cos to c, I have to write it somewhere, something else. I have two forms. I can write it as 1 minus 2 sine square c, or I can write it as 2
cos square
cos
c
square
minus 1.
c minus 1. Right? Which is the preferred one?
2
2
cos
cos
square
square c minus 1.
Okay. Cos a minus b, I'll keep it as it is, plus 2 cos square c minus 1.
Minus 1.
Okay.
You can take 2 cos c common.
2 cos c common. Very good. So I'll say 2 cos c into
Minus
I'll
cos.
take minus 2 cos is common.
Yes, sir.
Okay. I'll take minus 2 cos c common. I'll get this as cos a minus b. Correct?
Sir,
Hmm.
won't it be 2 cos square 2c minus 1?
Why did we get this? This one, no?
Yeah.
So this
Yes,
one,
sir.
cos
Is that an
2.
identity?
Yeah, it is an
Uh-huh.
identity. All the identities before I use, I'm going to write it here. Okay? These are all the identities for cos to c. In my trig videos, it was there, no? Did you manage to go through the Trigo videos?
Not all, sir. I just went through the beginning part.
You please go through them. Okay, today you have time. You can play it in 1.25 times the speed. You just go through that because sometimes I have the habit of going on and on and on. Okay, so you look at that. In those videos, these things are mentioned. Okay, cos to c has 3 formulae: 1 minus 2 sine square c, 2 cos square c minus 1, cos square c minus sine square c. Okay, that is the formula which we used.
Okay.
Where were we?
Thank you, sir.
No problem. So here I'll get minus cos c, correct? Correct, Noda? Because plus 2 cos square c was there, I took minus outside. Minus 2 cos c to minus cos c is 2 cos square c. Correct?
Yes, sir.
All right. Then I keep this minus out here. Then I have cos minus cos, right? I'll write this c as one more. Cos c is nothing but cos of 180 minus of a plus b. Correct?
Yes, sir. It will become minus cos a.
Minus cos, it will become minus
plus
cos a plus b. So this becomes
become plus
plus here. Cos
Cos
a
a
minus
minus
b plus.
Plus cos a plus b.
Very good. And from here, the part is easy. Cos plus cos. Okay, once again, we use the same formula. Minus 2 cos c into cos of sum of these angles, right? So I will have a minus b plus a plus b
A gets, b
by
gets
2. So I get cos 2a by 2 is cos a, and then a minus b minus a minus b. That means I'll get minus 2b by 2 minus b. Correct? And cos of minus b is nothing but cos b itself. Sine of minus theta is minus sine theta, but cos of minus theta is cos theta. So I'll get it as cos c. Right? And there is a 2 also involved in this. That 2 becomes 4. Correct?
Yes, sir.
Minus 1. That means I got...
So why is it cos C
So
over there?
So you put cos c instead of b.
Yeah.
Cos b, I'm so sorry. Minus b, so it is cos c. So what do I have now with me? I have minus 4 cos a, cos b, cos c, and I have a minus 1. Some goof up has happened.
I think we forgot to change the sign for minus 1.
Meaning?
You can't because it's a plus outside, there's not a minus.
Correct only.
And so, how did the minus 2 cos C become minus 4 cos C? Because there was no 2 in front of the cos A minus B.
Here I have to see, when I do this cos A minus B, cos A plus B, I have 2 here, no?
Yes, sir.
Right? Just check some mistake somewhere.
So in the step where we take the 2 cos C common,
Here.
yeah, it will become 1 minus cos C, right? So 1 will become positive.
No, that minus 1 is outside, no? We are not even,
Okay.
there is nothing common for 1.
Yes, I got it.
Sir, I think it's correct only. Like whatever you did.
Okay. That means here it should be minus 1, no?
Yes, I can't find the mistake.
So I think in the numerical, this should be minus 1, prove that. In prove that it is minus 1 minus 4 cos A cos B cos C. Okay?
Okay.
Because I carefully saw everything and yeah, it's okay. This is correct. All right. Any doubts so far?
No, sir.
Not all the time you get everything plus here. Sometimes you may get a minus also. Okay. Okay. Then with your permission, I will go to the next one. Someone's chatting. Yeah, Hannah, I tried calling her. Yesterday in the class also I said, no, today the class is at 11:30. She didn't join. I texted her also. Anyway, I'm recording this. So now we will come to a second type, okay? Where instead of just the sign, you have squares. For example, they say, yeah, you have a plus b plus c is equal to pi. Prove that sine square a plus sine square b plus sine square c. Okay? One example I'm taking 2 into 1 plus cos a cos b cos c. Okay? So what we have to do here is that same identities only, right? Can you tell me here what we should do? Adit, can you come up with some ideas? Because here you have squares and you have sine, here everything is cos.
Yes, sir.
क्या करें? If anyone is coming up with some ideas, you can tell me. Our question should be, yeah, how can I convert a sine square into a cos? Sine square a ko, how can I make him into cos a?
So you can use the formula of sine square x is equal to 1 plus cos 2x by 2.
Sine square x is equal to 1 plus cos 2x by 2. Okay, good job. So what you're telling me is, you just now discussed in the previous sum cos 2x is equal to 3 forms are there. 2 cos square x minus 1, 1 minus 2 sine square x and cos square x minus sine square x. There is a tan also, which we don't want now. So if I use this relation cos 2x is equal to this, from that I can get sine square x, right? So 2 sine square x is equal to 1 minus cos 2x, okay? Therefore, sine square x is equal to half of 1 minus cos 2x. Is it okay, guys? Very good, Vaishnavi. So, because I have everything sine square, for everything I can convert it into half of 1 minus cos 2x, right? So, please help me, Vaishnavi, now.
Okay, so it's going to be half 1 minus cos 2a.
Okay.
Plus, are we taking the a half completely common?
Yeah, because everywhere cos A, cos B, cos C, no?
Yeah, so you can just take the...
Same
okay,
thing.
Fine. 1 minus cos 2b and half plus 1 minus cos 2c.
All right. Then 1 half is there, half is there, half is there. It is 3 by 2?
Yeah.
Okay.
No, but when you take it common, it does not become 3 by 2, right?
No, I'm just separating it out. Half here, plus half here, plus half here. I'm not taking it common.
Yeah.
I'm just opening up the brackets.
Oh, okay, yeah, fine.
Make sense?
Sure.
So half plus half plus half is 3 by 2. Then cos 2a by 2, cos 2b by 2, cos 2c by 2, right? Minus. So minus half of cos 2a plus cos 2b
plus cos 2c.
plus cos 2c. Correct, no?
Yes, sir.
Good job. Now we got the way we wanted it, right? Now we know how to do this cos 2a, cos 2b manipulation we got. So when we had the square, we did some jugaad and we converted it into a plus b form, right? So please help me do this now. It is 3 by 2 minus half of...
minus 1 minus 4 cos a, cos b, cos c.
Cos 2a plus cos 2b, this is sum, right? So sum will be...
Can't we just use... we proved it like a minute ago. Can't we just use that?
You wanted to directly use that. Very good. Which one you want to use?
Cos 2a plus cos 2b plus cos 2c.
Minus 1 minus 4 cos a, cos b, cos c, right?
Yeah. Yeah.
Okay. So minus half of minus 1 minus 4 cos a, cos b, cos c. See, that is not like a ready-made identity for you to use in the exam, right?
Yeah.
But just because we did this numerical previously, I am allowing you to do it now because it's a waste of time, right? So, but in the examination, you have to take this as a separate problem and get this result.
Okay, sir.
Okay. Then here now you open the bracket 3 by 2 plus half, correct? And this will be 4 by 2 is 2 cos A, cos B, cos C. Then you have 3 by 2 plus half. 3 by 2 plus half is 4 by 2 is 2. 2 plus 2 cos A, cos B, cos C, or 2 into 1 plus cos A, cos B, cos C.
So here we have verified that the last numerical was wrong, the proving part. So it is
Correct,
actually...
correct. So because we got this right,
yeah,
it had to be minus 1 only. Very good. Because even in textbooks, no, their numericals, sometimes they make a misprint. All right, so this is how the squares can be converted into product. Okay, go ahead and make a note of this, guys. I'll choose the next one for you. Guys, any person, any doubt, please stop me. Let's discuss.
Sir,
Tell me.
I have a doubt.
Hmm.
Where did minus 1, how did you take minus 1 by 2 common in the third step? I mean, second step.
Okay, expand this for me.
1 by 2 into 1 minus cos 2. Huh?
No, da.
Oh, cos 2a by 2. Okay, got it.
Hmm.
Okay, fine.
Any other questions? Can I move on to the next one, guys?
Yes, sir.
Yes, sir.
Yes, sir.
You may be sometimes given numericals which look a little confusing. Okay, let's try to, we have to handle this very smoothly. Okay, if a plus b plus c is equal to, or they may say in a triangle ABC. In a triangle ABC. Okay, that means it is given a plus b plus c is equal to pi. Prove that. Cos square a plus cos square a plus pi by 3 plus cos square a minus pi by 3 equal to 3 by 2. Okay, so Karan, I want you to fix your mic, Karan, Krutik. Vesu sometimes speaks, sometimes doesn't speak. Kritik, I think you have to. Karan, can you speak or not speak now? All right. So I'll do. Neha, come. Let's solve this together.
Okay.
So last time around, we used the identity for cos 2x is equal to 1 minus 2 sine square x, right? This time around, we have to use the identity cos 2x is equal to 2 cos square x minus 1, right? Because we have cos square. And then we'll just write it. So 2 cos square x is equal to cos 2x minus 1, right? Plus 1. 2 cos square x is equal to cos 2x plus 1, or cos square x is equal to 1 plus cos 2x by 2, or we can say half of 1 plus cos 2x. Sometimes 1 plus cos 2x by 2, by mistake people write it off like this. This is wrong. It is half of 1 plus cos 2x. Okay. With that, how can we write this, ma?
It will be half of 1 plus cos 2a plus half of 1 plus cos 2a plus pi by 3.
Yeah. The whole thing is the angle, right?
Yes.
Very good.
Cos 2a plus 2 pi.
2 into a plus pi by 3. That's what you're telling, right?
Yes, sir.
That means it will become 2a plus 2 pi by 3. Can I write it like that?
Yes.
Cos of 2a plus 2 pi by 3, right? And then plus half of 1 plus cos of, instead of 2a, I have to write 2 times of a minus pi by 3. 2 times of a minus pi by 3 will be 2a minus 2 pi by 3. All right. So once again, we do this 1 by 2, 1 by 2, 1 by 2. Kitna ho gaya? 3 by 2. Plus, tell me what should I do, Neha?
1 by 2 into cos 2a plus cos 2a plus 2 pi by 3. Plus cos 2a minus 2 pi by 3.
All right. So here everything has to become 3 by 2, right?
Yes.
So what to do next? So this is, we leave this guy alone, okay? Because these guys are in the form of cos 2a plus 2 pi by 3, cos 2a minus 2 pi by 3. We will club these two guys together. Do you agree with me?
Yes, sir.
Okay. So this guy, I'll kind of take him out because I want to work only with this. So that will become 3 by 2 plus half cos 2a. I'm separating it out from this bunch. Plus half of, right? I've taken this guy, I put him in separate. This one is cos a plus cos b. What is the formula for cos a plus cos b?
Cos a plus b by 2.
Very good. So it will be, I'll write it here, cos x plus cos y is 2 cos x plus y by 2 into, tell me ma?
Cos x minus y by 2.
Cos x minus y by 2. This is a formula which we all know. Time and again I'm writing it. Okay, so for us here, it is going to be 2a plus 2 pi by 3. This is going to be x plus y. 2a minus 2 pi by 3, whole thing divided by 2, angle divided by 2 here. So this and this will go, 2a plus 2a is 4a by 2 is 2a. Agreed, huh?
Yeah.
Okay, so you have cos 2a inside, okay? Then here it is x minus y by 2. 2a plus 2 pi by 3 minus 2a plus 2 pi by 3. This will go off 4 pi by 3 by 2 will be 2 pi by 3. Correct?
Yes, sir.
Sir, it won't be cos 2a, right? It'll just be cos a because it's divided by 2. Oh, no, never mind. Sorry.
Yeah, 4 hai na?
I didn't see that.
No problem. Because sometimes because I keep speaking, I make some mistakes. 2a plus 2b by 2. So it will become cos 2a, and this is cos 2 pi by 3. Correct? All right. Now, this cos 2 pi by 3, we know what this guy is, right? Guys, do you know what cos 2 pi by 3 is?
Yes, sir.
So
Cos
120.
120.
Yeah.
Instead of saying cos 120,
90 plus
90
30.
plus 30.
it is cos of
In the
pi
bracket.
minus pi by 3, right?
Yes.
So minus 1 by 2.
So cos 2 pi by 3 is cos pi minus pi by 3.
Minus sign.
So it will be a pi minus, hello, 180 minus.
Oh yeah, yeah.
180 minus, you will not get sine. Please be careful, right? Minus cos pi by 3. And what is minus cos pi by 3 H2?
1 by 2. So it will be minus 1 by 2.
Minus 1 by 2. Okay, with your permission, I will write this as minus 1 by 2. So I get this as 3 by 2 plus 1 by 2 cos 2a plus cos 2a by 2.
So will there not be a 2 in the bracket like 2 cos 2a because
Very good. Thank you. Because this is 2 into, right?
yeah.
That 2 and this 2 will cancel. So here I will not have, divided by 2 will not be there, correct? Because that product and this outside common will get cancelled. So this will be cos 2a into, but here we have this whole thing is minus half, right? Into minus half. Agreed? This cos 2 pi by 3 is nothing but
So that will get cancelled.
We'll see that. So it is 3 by 2 plus half cos 2a minus half. Okay, so we got our answer 3 by 2. So carefully, guys, instead of copying, no, I want you to do this yourself. Okay, you might have seen it. This little care you need, because we have a plus pi by 3, a minus pi by 3. You have your rough word column, carefully add it. Then you don't do everything here. Then it becomes very ugly. Always when doing these sums, you should have a wide rough word column. Okay, and make all the manipulations you want here and then transpose it here. Okay, I want you to do it by yourself. And if you have doubts, let me know. I will get back to that slide.
ನೀವು ಬರ್ದಿಲ್ಲ ಅಲ್ಲ? Okay.
Who are you waiting for, Hannah?
So my network went down, so there was like literally nothing on the screen.
Oh, is it? Now you got it?
Yeah. Yeah, now I'm back.
Okay. See, sometimes if you don't have broadband Noma, you can just turn the hotspot on and connect to your hotspot in your laptop. Okay. In fact, that's how I am doing now. I am streaming my PPT, everything I am doing with my hotspot only.
Okay, sir.
Okay, so because your Wi-Fi may be used by multiple people, it may sometimes become slow. But one phone means it is dedicated to you. Okay.
Okay, sir.
Yeah, I am connected to my phone's hotspot. I just verified. All right, guys. So, Hannah, did you get this numerical? If your Wi-Fi, if your phone was not there, did you understand this numerical, Hannah? I think she went off again. Hannah, you're on mute, I think.
Oh, so I think my screen went off when we were still here, 3 by 2 plus 1 by 2 into cos 2a. So can you explain from there?
From where? Tell me.
From there, sir.
From here?
No, the next step.
the next step.
Yeah.
So what we are doing is we are taking these two guys common. Okay, because we say 2a plus 2 pi by 3, 2a minus 2 pi by 3 is there. We are taking this as cos x plus cos y. Okay, and then what we are doing is we are using our formula, the sum product. Cos x plus cos y is 2 cos x plus y by 2 cos x minus y by 2. Okay.
Yes, sir.
And then that you are manipulating x plus y. This is x plus y by 2. I just did this in the rough work. So you whole thing divided by 2, you just get cos 2a. That's what we have put here. Are you able to understand?
Yes, sir.
And cos x minus y will be, this is x, 2a plus 2 pi by 3. This is x. I'll just write it for you. This whole thing is x minus this whole thing was y. 2a minus
Yes, sir.
2 pi by 3 was y. So when you have minus, it becomes minus 2a plus 2 pi by 3. Minus 2a plus. This will get cancelled. You have this plus this. 4 pi by 3 by 2 will once again become 2 pi by 3. Okay? And cos 2 pi by 3 we know is cos of 180 minus pi by 3, whose value is minus cos pi by 3. That minus cos pi by 3 is minus half. Okay? All right, guys, could you do it yourself?
Yes, sir.
Yes, sir.
Anyone still doing? Should I wait for you? Naina, are we good, ma?
Yes, sir.
Neha?
Yes, sir.
Veshu?
Yes, sir.
Yes, sir.
Okay, and Vesu also, very good. Veshu and Vesu are like similar sounding. Good. Now, the last kind of identities we will get are involving tan. So we saw just sin A plus sin B plus sin C types we have seen. Okay, we have seen cos A plus cos B plus cos C. We have seen both sin square A and we have seen cos square, right? All this we have seen, right? Now, the one which is left is that which involves tan, right? So, in a triangle, prove that tan A plus tan B plus tan C equal to tan A, tan B, tan C. Okay, so what we do here is, we have seen here, this is tan A plus tan B is there, tan A, tan B, tan C is there. Okay, so you know intuitively, you have to work with A plus B and tan of A plus B. That's where you get tan A plus tan B, right? So we will do that. We will say, yeah, you have told me this is angles of a triangle. So A plus B plus C is equal to pi. That means A plus B is going to be pi minus C, right? I will take tan on both sides. Tan of A plus B is going to be equal to tan of 180 minus C. Tan A plus B is what? Tan A plus tan B by 1 minus tan A tan B, correct?
Yes, sir.
Is equal to tan 180 minus theta. Tan 180 minus theta is minus tan C. Agreed? Tan 180 minus theta.
Yes, sir.
Tan remains tan. Second quadrant, only sign is positive. Now we will try to cross multiply. Tan A plus tan B is going to be minus tan C into 1 minus tan A tan B. If I open this, you'll get minus tan C plus tan A, tan B, tan C. Okay, then you get it this side. Tan A plus tan B plus tan C equal to tan A, tan B, tan C. All right. So just make a note of this. We will do other sums. Any questions around this, guys? Easy, no? This is very simple. The moment you know you have to take tan on both sides, your answer is in front of you. All right, shall I move ahead? This
Yes,
also is
sir.
this also is a very popular sum. Okay, in the if ABC are the angles of a triangle, prove that. Okay, so Adit, how shall we do this now?
So if we do the same thing, do we
Yes,
take...
similar thing. Okay.
Okay. So we have to bring one side to the right. Yeah, so A plus B is equal to pi minus C.
Then you realize that, yeah, last time around when I did this, I got everything tan A plus tan B, but here I need everything A by 2, B by 2, isn't it?
Yes, sir.
So we will be smart and say, yeah, I want A plus B by 2, okay, is equal to pi minus C by 2. You're able to understand?
Yes, sir.
This is the only smart thing we'll do in this case, okay? That means we are saying A by 2 plus B by 2 is equal to 90 minus C by 2.
Yes, sir.
All right. Then what we do, we say with this result, I will take tan on both the sides, right?
Yeah.
So tan of A by 2 plus B by 2 equal to tan of, okay, wow.
Yes, sir.
ठीक है. But tan of 90 minus C is what?
Cot C by 2.
Very good. Tan of 90 minus C is going to be cot C.
So we
90
can take it as
minus
1 by...
that we will do later. Step by step jayenge. I don't know
Yes,
what
sir.
it will come for. How it will take shape. And this is tan A plus tan B. So then I'll say tan A plus tan B by
1 minus
1
tan A
minus
minus.
equal to cot C by 2. Okay, then here I see I have tan A by 2 plus tan B by 2. But here everything is, this side I'll get a product, this side I'll get, so what do I do now?
1 by tan C by 2.
Now I will say, hey, this cot C by 2 is there. No, I will write this as 1 by tan C by 2. Okay, then what will happen is, this will go on top, this will come here, I will get product everywhere. Okay, then after writing this, I will cross multiply. Okay, so I'll say tan C by 2 into tan A by 2 plus tan B by 2. Correct, from here it went on top, is equal to 1 minus tan A by 2 into tan B by 2. All right, then what I do,
Yes.
if I want to get this, only one I have to have. So get this, I get this side. So I say tan A by 2, tan C by 2 plus, open the brackets basically, tan B by 2, tan C by 2. Then this I get this side, tan A by 2, tan B by 2 equal to 1.
So for all the tan sums, we should like take the angles and then multiply it by tan.
Yes, yes. So these are all very typical. Okay. In fact, I'm spending more time, much more than required on these things. In your school, they will just rush this. They will not do it the way we are doing here. I am doing this because you should have comfort in Trigo, okay? And that is going to help us in our competitive exams also. All types we should be doing. So what you guys should do, no, as the exercises are progressing, one, you have my assignment that keeps getting uploaded in Google Classroom. But don't wait for me to tell you to do NCERT and RS Agrawal completed exercises by yourself. This whatever is there, you have to fatafat do it. I am not going to ask you time and again, did you do those exercises or not? Remember, 11th and 12th, you have to act mature, right? There is no policing that will be done. You use me to help you guys succeed. If you want me to start policing you and all, this is not going to happen, right? So self-motivation should be there for you because you need to succeed. 8th and all, people start cheating, they'll say they lie and all that, right? That simply is not going to happen. You got to help yourself. Okay, unless you do this and my assignment, okay, you're not ready. After this, you have to start doing RD Sharma. That is the path for people who want to do IIT mains, BITS Pilani, CET. For CET, you don't need RD Sharma. If your goal is just CET, NCERT or Sagrawal assignment is good enough. You want to go one step higher, BITS Pilani and all you want, then you have to do RD Sharma and mains. IIT Advanced anyway, I'm not claiming to coach them. You will have to do much more. Okay, a minimum per topic, you should clock 100 numericals. Every topic that I teach, minimum your practice should be 100 numericals. That means you're doing justice. So if you're finding time to do Netflix and some other nonsense, then you know you're not doing your job. Just put the 12th examination completed, only 1 month will be there, all exams will come for you, 5-6 exams, you will not have time. So utilize these 2 years very, very judiciously. Don't wait for people to, monitor you, mentor you. Self. Everything is self. Because for the first time in your life, you're trying to wipe your own butt. If I can say this, no? Wipe your own butt. Don't expect your parents, your teachers to change the diapers for you. You're no longer kids. You're all adults. Is my messaging clear? Because I have to make it very, very clear. This is your life. This is your goal. This is your career. All this is for you. So you should take care of yourself. Okay, Bhashan time is over. Let's get to... Any doubts with this, guys? These two numericals?
No, sir.
No, sir.
Some people know, they feel, yeah, itna, why should I do so much? This is after all my life and I want to have some free time. Why is the environment so bad, and why we have to struggle so much and all this stuff? But that's the reality of the situation, right? If you were in some other country, so many people are not vying for the top schools. We are a very populous country. That's the reality. And we are not saying that only science is great or whatever, but once you have chosen it, the competition is such. Okay. So we all are victims of our environment. We have to revel in that. Guys, any questions?
No, sir.
All right.
Yes, sir.
So I'm now moving on to a new topic, which is called trigonometric equations. Okay. In this, you need to know that you will be getting linear equations, quadratic equations you are solving, right? Here, you will be getting equations in sine theta, cos theta, tan theta. Okay. So you have to convert them. Okay. And then you have to find what are called principal solution and general solution. These two things are there. Okay. Sure, Lina, I will do that for you. Thanks for texting me here. In fact, you can chat also. Okay. So let's go step by step. Okay. If we take a simple case, for example, I say, boss, sin x is equal to some value. Let's take pi by 4. 1 by root 2. What can you tell me?
X is 45.
X is equal to 45 degrees or pi by 4. Okay. Supposing I say sin x is equal to half. What can you tell me?
X is 5 by 6.
Sin 30, right? But you know that this sine function is there. No, it is cyclic. That means it is going to repeat itself. Isn't it? So if I have one value here, this is plus 1. Okay. Guys, please pay attention a bit closer. This is 1. I'm going to get 1 once again. I'm going to get 1 once again. Okay. So that means this value you are not going to get just once. You're going to get multiple times as you are, having more and more cycles, right? One other way you can represent this is like this. Right? So when this point is going around this circle, when this point is going around this circle, you're going to get the values of sine theta, cos theta and all, right? So that means opposite side by hypotenuse. This is going to be x, okay? This is going to be y. So as you keep going around this circle, for sine the values are going to repeat, yes or no? But when you are looking at the principal value, you are looking at the value which is between 0 and 2 pi. That is what is called the principal value. First time around, between 0 to 2 pi, when your x is present, that is called the principal value.
So 2 pi or pi by 2?
2 pi, that is the first cycle.
Oh, okay, sir.
One complete cycle, whatever you get, that is going to be the principal value. And later on, generic solution will be when the cycle is repeating. First round ho gaya. From here, I came here. So that is the first round. In the first round, you will get some answer like 1 by root 2, pi by 6, etc. That same thing you will get in the second round also, as the wheel keeps turning. First round ho gaya. This is second round. That second round will be n is equal to 2. Third round will be n is equal to 3. So as the wheel keeps turning, it is going to generate more and more cycles of the sine values, which will repeat. Okay. So first time around is called principal solution. When x is going to lie between 0 and 2 pi. It is called the principal solution. And when it repeats itself, it is called the generic solution or general solution. Okay, so general solution is because of the periodicity of the sine function, tan, even sine, cos, even tan. Okay, we have seen how the shape of these functions are. Sine and cosine are similar to each other. They are this. We call them sinusoidal functions. We have also seen how the functions for tan resemble, right? Tan also will be repeating itself. They'll have a pattern like this, isn't it? So, did you understand what you mean by principal solution and general solution? Huh? If, for example, you have sine theta is equal to 0, okay, then we know, hey, when is theta going to be 0? You will say sine 0, correct?
Yes, sir.
What is the next value when theta is going to become 0?
Sine 180.
Sine pi. Okay. Next. What
Sine 2 pi.
Sine 2 pi. Very good.
P pi and all the natural numbers.
All the 3 and so on. Okay. Then you say, okay, first time around I know this. Sine 0, it is 0. Sine pi and sine 2 pi. Then I am seeing that every time it keeps adding 180, 180, 180, I am getting 0 only. Okay. So if I want to write this in a generic form, right? Because now I am talking about a generic way of expressing the solution for this, right? So this is called general solution. By our observation, we say sine 0, 0 means my theta can be, okay, sine 0, it can be pi, it can be 2 pi, it can be 3 pi, so on. So for this, what we do, we say, yeah, theta is equal to n pi. Okay, and I will say n belongs to integer. Okay, because this can be positive and negative also. Theta belongs to integer. So this what we are telling when we have written n pi, this means this is the generic solution. So when you have sine theta is equal to 0, if you are able to say theta is equal to n pi, where n belongs to integers, that means you are offering a generic solution for the given equation. The equation that you had is sine theta is equal to 0. You are examining here. You have seen that it is possible for multiple times. And here, instead of leaving it like this, you are coming out with a generic solution. And you are telling what can be n, right? So when you substitute n as 1, 2, 3, 0, all the cases, this is going to get satisfied. So you call this theta is equal to n pi, where n belongs to integer, as the generic equation for the given equation sine theta is equal to 0. Did you guys understand?
Yes, sir.
Okay, can you please make a note of it? I'll go very slowly here. It's not only on the positive, even negative also. N is integer. Don't mistake this as whole numbers or natural number. It can be minus infinity to plus infinity in discrete steps, including 0. Now, are you done with this?
Yes, sir.
Yes, sir.
Yes, sir.
Let's look at the next guy, okay? Supposing I have cos theta is equal to 0. Okay, then we'll say, let's look at it. First I know cos 0, 1. Cos 0 is 1, so I can't take 0. Cos of pi by 2, correct? Cos pi by 2 is going to be 0. What next?
3 pi by 2.
Cos 180 is? What is cos 180?
Minus 1.
Minus 1, so we leave it. Then cos of 3 pi by 2.
70.
Then cos of 5 pi by 2, correct?
Yes, sir.
So then what we will do is, how do I keep this in a generic form? This is the first time it becomes 0, but later on, I am seeing that as the wagon wheel is moving for me, when it is in this fashion, okay, plus or minus, of course, we are only looking at plus now. We are able to get the same situation again, okay? So how can I put pi by 2, 3 pi by 2, 5 pi by 2 in a generic form? Okay, then you realize that if I take this as 2n plus 1 into pi by 2. Let's just examine this. If I have a form, a generic equation 2n plus 1 into pi by 2, and if I tell n belongs to integers, okay, let's only take positive integers for now. Negative also it is going to work. N is equal to 0. N is equal to 0 means I get pi by 2. Then I put n is equal to 1. 2 into 1 plus 1, 3 pi by 2, right? N is equal to 1 will give me 3 pi by 2. N is equal to 2. 4 plus 1, 5 pi by 2. Okay, so I quickly realized that if I frame 2n plus 1 into pi by 2, that is going to satisfy this. Okay, so whenever I have cos theta is equal to 0, I can write the solution as theta is going to be equal to 2n plus 1 into pi by 2. I have to quickly clarify that my n belongs to integers. So it is equally applicable to cos minus pi by 2, cos minus 3 pi by 2, etc. So this is going to be the generic equation, rather generic solution. For the equation cos theta is equal to 0. All right, guys, did you make a note of this?
Yes, sir.
Okay,
Yes,
so we
sir.
discussed.
So 1 second.
Yeah, take your time.
So you can move forward.
What is it, ma'am?
You can move forward. I'm done.
Okay. Then the last one, before I want to do one numerical possibly today, is the generic solution for tan. So if I have tan theta is equal to 0, in the similar fashion, I can say, boss, your theta has to be equal to n pi, okay, where n is belonging to integers, okay. So whenever you are having this case, tan theta is equal to 0 type of an equation, this is going to be.
So isn't it only odd numbers?
Only odd, right?
2 pi is 1. Like for tan theta, like tan 360 is 1.
How da? Sin 360 by cos 360, no?
Yes. Oh, okay. Sorry, my bad.
Cos 360 is 1, but sin 360 is 0.
Got it, sir.
So it works for pi, it works for 2 pi, 3 pi. N pi is the generic solution. Okay. So to reiterate, Adi, sin theta is equal to 0 means what is the generic solution?
Theta is equal to n pi, where n belongs to integers.
Okay, that is sin theta. What is tan theta is equal to 0 means?
It's going to be the same thing.
Same thing. For sine and tan, when sin theta is equal to 0, the generic solution is the same. Correct?
Yes, sir.
Whereas for Vaishnavi, cos theta is equal to 0 means what is the generic solution?
2n plus 1
into
theta by 2.
Into pi by 2. And n again belongs to integer. Please don't take only positive. It is positive as well as negative, right? Integers. So with this, what we can do, we will do 1 or 2 numericals and then we'll call it a day. Thank you so much for your patience. You have been a very wonderful crowd. So I will take my dearest friend Nihar. Sin 2x is equal to 0.
Yes, sir.
How do I do that, ma?
So we know that sin pi if sine pi equals 0,
We'll say if
then
sine theta is equal to 0,
yeah, then
that
the
means theta
generic
has to
solution
be n pi.
equals n pi. Yeah,
Okay. So here, what is my theta?
x. No, 2 pi.
2x, because this is the theta,
Yeah,
isn't
2x.
it? So sine 2x is equal to 0. This means 2x is equal to n pi.
N pi. Yeah.
Okay, that means what should be my x? Because that is what, no, when you're doing a quadratic, you will find the value of x.
Yeah.
This is what the solution is. So x will be
N pi by 2.
n pi by 2, where n belongs to I. Okay, so this is your generic solution. You are recognizing that this is in the form of sine theta is equal to 0. And you're comparing when sine theta is equal to 0, theta is equal to n pi is the generic solution. So you're substituting 2x as theta and getting the generic solution as x is equal to n pi by 2, where n belongs to integers. Is it okay?
Yes, sir.
Right. Now, my dear friend Naina, cos x plus pi by 10 equal to 0. Naina,
Yes.
what should I do? What is the generic solution for cos theta is equal to 0?
So x plus 10 will equal to 2 plus
X plus 10 is equal to? That always happens with her. Her internet is choppy.
So x plus 10 is equal to 2n plus 1 into pi by 2.
Very
So
good.
x will equal to 2n plus
2n into pi by 2 plus pi by 2 minus pi by 10. Correct?
Yes.
Just
Yes, sir.
you are moving it there, right?
Yes.
So either you can simplify this or you can just write it as, because they want this form. So you can say x is equal to 2n plus 1 into pi by 2 minus pi by 10. You can leave it like that.
Yes.
Sorry, not here. Here. X is equal to 2n plus 1 into pi by 2 minus pi by 10. Of course, you have to mention n belongs to I. All right. Next, supposing we say, this is my friend Adit. Tan 2x plus pi by 8 is equal to 0. Supposing I say this, what will you do?
So 2x plus pi by 8 is equal to n pi, and then we substitute.
So you'll say, hey, I know when tan theta is equal to 0. See that this is tan theta is equal to 0. This is of this form. Tan theta is equal to 0. Theta is equal to n pi. Our theta is 2x plus pi by 8.
Pi by 8.
Okay. Then what will you do? You say, therefore 2x is equal to n pi minus pi by 8. Or x is going to be equal to
1 by 2 into
n pi by 2 minus pi by 16. Correct?
Yes, sir.
Or you can say that as pi by 2 into n minus 1 by 8. Just trying to simplify it a bit.
Yes, sir.
Or you can leave it as half of you try to retain the form tan theta is equal to n pi. No, simplification this also is fine, but if you leave it as n pi, that will be more apt. So half of n pi minus pi by 8. Is it okay?
Yes, sir.
So guys, any questions around this?
No, sir.
Okay, see, this trigonometric equations is a very popular topic. Once again, you can expect questions, but this is only limited to 11th. In 12th, we don't have much of this, okay? But the other identities which you have learned, that cos x by 2, sin square x by 2, all that is useful. But this is like only limited to 11th, okay? So we will continue on this next weekend. As I was telling, please stay in step, okay? And do the questions from other textbooks as well, okay? I will upload one assignment for you in the next 1 or 2 days. Chalo, thank you. Have a great weekend.
Bye,
Let's
sir.
meet again.
Thank
Bye,
you,
sir.
sir.
Thank you, sir. Bye.
Bye.
Thank
Bye.